Good evening, everyone. Welcome to this ground improvement class. And My name is Rajat Bonik. I am from IITSM Dhanbad. I am a one of PMRF research scholar at IITSM Dhanbad, and also taking this ground improvement class, which is conducted by Nptel team. And these lectures already taught by Professor Dilip Kumar Bhattacharya on Nptel. I am just uh, discussing the weekly lectures in 2 hours and give you idea about these lectures and also give idea to about the to solve the assignment problem. And one and two points I mention here that this lectures is recorded and it will be shared you through NPTL on my YouTube channel. And also whatever I am discussing in this session, it will also uploaded on my Google Drive. It is also shared by NPTL team. Don't worry about that. And if my network is disconnected, please don't worry. Stay on the line. I will join in very quick time. So don't worry about that. And this session is about 2 hours. And in this session, I first discuss about the lectures which is taught in this week, and then I try to solve one or two problem, and then I will discuss about the assignment, previous year assignment problem, which will help you to solve the present assignment problems about this ground improvement. And let's start our session, which is already 6-7. And today uh, uh, we will discuss about the another new topic about ground improvement. And so first I share my presentation. Please wait few seconds or few minutes. I will share my presentation. Please wait. Uh, please give me a minute. I arrange something. Uh, I think my presentation is visual to everyone, and also my audio also clear. So now we'll start our session, today's session. It is another new topic about ground improvement, which is chemical stabilization. Like others, ground improvement technique, this technique also improve or stabilize the ground through chemical reaction. So before whatever we discuss about whatever discuss about the ground improvement or different techniques, it is based on the physical change. That means we change only physical manner. That means we change a loose state to dense state. Like that way, we improve the ground. But in this chemical stabilization, we actually modify the minerals or modify the bonding strength of the soil through chemical reaction, and also completely change the chemical property of the soil and modify it for our need or purpose, whatever like that. So this technique is different for other techniques. We completely different because we apply the chemical reaction instead of physical improvement. Where we only change the physical state of the soil. No, don't not change about the chemical property of the soil. And but here we for stabilization we use chemical reaction. So let's start our today's session. So first, it is one point is given here there. Soil stabilization. What do you mean by soil stabilization? Actually, whatever we're doing still now to improve the ground is about soil stabilization. Whether it is in a physical way, whether it is chemical way. So in soil stabilization, is divided in two ways. On physical way, that means in mechanical energy is and others chemical way. Where is chemical reaction. So in soil stabilization, it is said that procedure in which a special soil is proportional, add or remove, or a cementing material or other chemical material is added to a natural soil material to improve one or more of its properties. So in soil stabilization, we actually mixing, removing, or add some good material, or mixing some cemented material. Like that way, we improve the soil properties. This is called soil stabilization. So one example also given here. It is said that mixing of natural coarse grain soil and fine grain soil to obtain a mixture that develops adequate internal friction and cohesion and thereby provides a material that is workable during the placement but will stable further and called mechanical stabilization. That means here one example given that we mixing coarse grain with fine grain. By mixing coarse grain fine grain, the pore space coarse between the coarse grain is taken place in fine grain, and the bonding or interfriction is between the particle is increased. Also cohesion between the soil particle also increase. So like that way we improve the soil. But here we do not use any chemical reaction or chemical changes. So by this way, when we apply or change the soil or modify the soil, it is called the mechanical stabilization. So in the next slide, it is said about the chemical stabilization. Whatever it is, the chemical stabilization. The simple, by simple definition, it is that when we mix some additives or cementing material to the soil to improve the bonding cohesion, then by that way, when we improve the soil properties, this is called chemical stabilization in simple way. But here, simple way. And here it is said that stabilization can also be achieved by mechanical mixing the natural soil or stabilized material together so as to obtain a homogeneous mixture. After the soil and stabilizing agent are blended and work together, they are compacted using an appropriate compaction device. The stabilizing material include cement, lime, bitumen, asphalt, polymer, and other mineral chemical. That means the bonding material here is stabilizing material. So and it is divided here in many ways like cement, lime, bitumen, asphalt, polymer, and other chemicals like that. And when we apply it is on the in soil in some specified proportion, and after that when we mixing in homogeneous way and apply the compaction or compacted that, then by this way when we improve the ground, this is called the chemical stabilization. So now we discuss about the need of the soil stabilization. The main purpose of for the soil stabilization to increase the strength of the soil. And also, if you remember that whatever the technique till now we discussed about the ground improvement, every technique first stage is to improve use to improve the strength of the soil. And so, like that way, the soil stabilization also, that means chemical stabilization also used to increase the strength of the soil. So, it is said that in case of a cohesionless soil, the strength could be improved by providing a confinement or by adding cohesion with a cementing or binding agent. And in case of cohesive soil, the strength could be increased by uh, drying making the soil moisture resistant and altering the clay electoral concentration, increase the cohesion with cementing agent and adding frictional properties. If you remember, if you know that in soil mechanics we study the cohesionless soil and also cohesive soil. The main properties of the cohesionless soil is internal friction. The binding or bond between is defined between the particular is defined by the internal friction only. There is no cohesion, or there is attraction, repulsion in between the cohesionless soil. So for improve the cohesionless soil, we provide the confinement. That is, if here one loose cohesionless soil is present, we need to improve this loose cohesionless soil in denser state. We confine this loose cohesionless soil around it, or apply the confinement around it. By this way, one way we improve cohesionless soil, or we add some cohesion or additive material like cement material or bituminous material to improve this type of or improve the cohesion or cohesionless soil by adding some additives or cohesion onto it. And if you remember, in cohesive nature of the cohesive soil, there is no internal friction in between the cohesive soil. So to improve this cohesive soil, we add some material which increase the frictional properties. Or if you know that the most of the cohesive soil is less permeable or impermeable in nature, so they try to uh, absorb or try to contain more water on it or water content on it. So which is not suitable in our construction purpose. So we apply some additives or some chemicals which used to dry this cohesive soil. So for that way also we use this soil stabilization in cohesive soil, and also we use the altering the clay electrolyte concentration. We know that the if clay particular mineral are very sensitive to soiling and sinkage. So if the concentration of the clay mineral if we alter, then the soiling and sinkage property may reduce, which is better for our construction. So for this purpose only, we use this soil stabilization technique in, or we can say very specifically, we can say that this chemical stabilization technique. So in the next slide, we discuss other need of the stabilization. What are the other needs? What are the other application of this soil stabilization? So it is said that compressibility can be reduced by consolidation by filling the voids with an appropriate material, cementing the grains with rigid material, or by altering the interparticle electrical force. So we can reduce the compressibility through this soil stimulation by different way, like consolidation or like filling the void space, or we can use the cementing material to make it rigid material, and altering the interparticle electrical forces. Or also we can use this simulation to reduce or control the soiling and sinkage properties of the soil by adding some cementing agent or by altering the double layer thickness, and and by preventing the moisture changes. So like that way we also use these techniques for soiling and sinkage also. And we can also use to reduce the permeability of the soil by filling the voids of an impervious material with an impervious material, or by creating a dispersed structure of the soil. So, like that way, different way, we use this soil stabilization for different purpose. One is to improve the strength of the soil by considering the cohesionless or cohesive soil, to improve different way. And after also we use it is to reduce the compressibility, to reduce the soil and sinkage nature of the soil, and also to reduce the permeability of the soil. So this different way we improve or we use this soil stabilization. So now we classify the soil stabilization based on the different function or different effects. So first one is classification. First one is mechanical stabilization. Second one is cementing. Third one is physiochemical alteration. Then aggregates or dispersion method. Then void filling method. Then consolidation method. So in mechanical stabilization, we improving the soil gradation or arrangement. That means we improve the loose soil into a denser state and increase the strength of the soil. In cementing, we apply the binding particles like cement or lime, and then binding the soil particle together without their alteration. And physiochemical alteration, changing the chemical minerals or clay minerals or clay water system. That means we change the any cations which is in between many clay minerals. We change it and it becomes we change its soiling and sinkage nature by that way. And also we control the clay water system also by uh, 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 weakening the by reducing the thickness of double layer of the clay particle. And in aggregates and dispersion, we alter the electrical force between the soil particles in modest way. Void filling with plunging in voids. Consolidation, we already discussed about the consolidation. In consolidation, we reduce the voids by removal of the water. By this different way, we stabilize or improve our soil. Uh, now we discuss about the chemical stabilization. Before discussing the chemical stabilization, we discuss about the different chemical stabilizer. What are the different chemicals we use to improve our ground? So here few examples is given. First one is given here quick lime, then given lime clean dust, then hydrated lime also used, then cement material also used, then cement clean dust also used, then class C fly ash and class F fly ash also used. So these are the different chemicals or additives we can say binding material used to improve the ground through chemical stabilization to required for our irrigation. So how first now we discuss about the lime stabilization. So how it is used in the or we can say how many ways this lime is used to stabilize the ground as we now discuss. So there is three methods, three ways is given. First one is drying by drying method. Then it is given modification. Then it is given stabilization. So in by name also we can clearly understand the ways to improve the different ways to improve the ground through life. So now we discuss one by one these three different ways. The first one is lime used for drying. That means drying, how it is used for drying. So it is discussed that at a low dose rate, quicklime dries wet soil by removing free water from the soil to create a calcium hydroxide. That means it is slacked lime. We know that the lime is very affectionate in very affectionate in water. When we apply the lime in wet soil, it is quickly reacts with water and it's formed a calcium hydroxide. So by this way, we actually dried out the soil, and we use, or we can say then the soil become workable to use in the field, or most suitable to use for the construction. So by this way we remove the water through line. And then also when this lime react with the water, some amount of heat generated. This heat also help to evaporate water from the soil, chemically reacting with clay soil to reduce their water holding capacity. So this by this different way, that means when we apply lime to the soil, it is not only attract or remove the water through chemical reaction, but by also uh, by generating some amount of heat, it also evaporates some amount of water from the soil, and further the soil become dry, and which is workable. Also, uh, sorry for that. My network is not working. Uh, Please wait few minutes. Sorry for hello. Sorry for the interruption. I lost during my session. I lost my actually I lost my network. I'm again rejoin it. Sorry for this disturbance. Please wait for me. I again share my presentation. Please wait. I think it is hello. I think uh, I think my presentation is visible to everyone. So sorry for the interruption. Please wait. I sorry for that. I think it is everything is okay now. My presentation is visible, also visible to everyone. So we're discussing about the different way of use of different lime use in different way. First one is drying method. So we already discussed about the drying method. Uh, so let's start again. So we see that by chemical reaction, lime also reduce the water, and during chemical reaction, uh, 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 some amount of heat generated, which also help to evaporate water from the soil, and water soil become workable for our construction. So here it is given the chemical reaction. during the lime applied in the wet soil. So when we apply the lime, it means calcium oxide in wet soil. It reacts with the water in the wet soil and form calcium hydroxide, that means select lime and some amount of heat. So we can see that when we apply calcium, or we can say lime, it absorbs the water and also creates some amount of heat. So so by two ways it reduces the water during chemical reaction, also after the chemical reaction by some creating some amount of heat, and this heat used to further reduce or evaporate the soil. So now we discuss about the lime modification. So it is said that at a low doses rate, quicklime and slacklime modify plastic soil by changing chemistry of the soil water so the clay particles agglomerate and flocculate. That means we know that the clay particle is size of the clay particle is less than 2 micrometer. So when that means and it is chemically active, or we can say electrically active. So when we apply by this electrical force, it is absorb water. Due to this water, it creates some plasticity in the soil. So when we apply quick lime or slack lime, this plasticity of this clay soil changes due to the chemical reaction, and clay particles is become agglomerate and focculated. So by this way, we stabilize the modify the ground, and also this reduce the soil plasticity, decrease the optimum moisture content, and reduce the shrink or swell potential of the soil. So by this different way, this clay particle uh, increase or reduce the or plasticity, also reduce the optimum moisture content, and also reduce the shrinkage and soil. The improvement in the soil properties occurs over 1 to 2 days and may or may not be permanent. It means when it requires some amount of time to react with soil particles over and then create some chemical reaction. So and this reaction sometimes may be permanent or sometimes may not be permanent. So these are the points about the lime modification. Now we discuss about the lime stabilization, how it is used to stabilize the ground. So it said that at higher dose rates, quick lime and slack lime increase the pH of the soil and making the soil more alkali, and clay particles start to break. Due to this high pH, the mm, bonding between the clay particle is breaks and releasing the silica and alumina that combine with the calcium to produce the calcium silicate hydrate or calcium aluminate hydrate. If you know about if you in soil mechanics, we study about the minerals, soil minerals. So here we will study the clay minerals also. We know that clay minerals are formed in two amount content. One is silica, another one is alumina. So if we know that the clay minerals is electrically active, when we apply the lime, the pH of the water, soil water is increased. Due to the increased soil pH, the concentration of hydrogen, we can say the concentration H plus ion is increased. And this H plus ion is attract the negative ion or anion of the clay particle, and it is neutral. Electrical force become neutral of this clay particle, and then the bonding between electrical bond between this clay particle become breakdown, and then it release the silica and alumina. After that, this alumina and silica react with the calcium of the lime particle, lime, and produce two cementitious material which is also used in the cement. One is calcium silicate hydrate, another one is calcium aluminate hydrate. And these two cementitious materials further react with the soil particle and make the stronger bond between the soil particles. By this way, we stabilize the ground through lime. So also it is said that it reduces the plasticity and increase strength and stiffness, reduce shrinkage of soil potential during this application or during the application of this lime. And improvement of the soil occurs over the week and lasts indefinitely. That means the improvement, the strength gaining of the soil is improved day by day. That means in first day the strength is X amount of strength is increased. We can say if the strength is 10 kPa, it is increased to in few days. That means 10 days it is increased to 20 kPa. And this reaction is continuous process. So over the period of time, this strength is further increased. Like this way, this slime stimulation we suitable or benefits for the longer project, a longer gaining strength. So it is said that flocculate and agglomerate clay particles by replacing the monovalent cation such as Na with divalent cation calcium. But that means in clay it is present monovalent uh, cation sodium, which is replaced by divalent cation calcium. So we know that affection power of affection is more in we can say attractive power is more in calcium than sodium. So it is replaced with calcium, and then the bonding between the clay minerals is breakdown, and further the we already discussed that the silica and alumina is react with the calcium and cementous materials form. So cement clay particle together by creating a pozzolanic reaction between the lime and silica and alumina. So by this way we know that lime, silica and alumina, it is also called the pozzolanic uh, uh, content. So when it is combining these three, cementous material is created. So this cementous material is used for the stabilization of the ground. And one further one point here it is given that clay cement particle together by creating calcium carbonate from lime plus atmospheric carbon dioxide. So last point we discuss about the chemical reaction in lime of lime when it is applied to the ground. And we also know that calcium carbonate is a good material to cementous materials also. So further, now we discuss about the chemical reaction happen in the lime. So it is said that two types of chemical reaction take place when lime is added to the wet soil. So the first one occurring almost immediately in a is a colloidal type of reaction involving any of the following. So two reaction is happen during when we apply the lime to the soil, and the first reaction is happen when immediately after applying the lime, and it is happen in three ways. First one is ion exchange of calcium for the ion naturally carried by the soil. Second one is a depression of double layer on the soil colloid because because of the increase in cation concentration in the pore water. Third one is an expansion of the double layer of the soil colloids from the high pH of the lime. So in three different ways, first reaction is happen. First one ion exchange is happen between the soil particle and the lime. Then the depression of the double layer is happen by when okay, exchanging the cations to the pore water during the line, applying of the line. Then also the expansion of the double layer is happening, and when the uh, pH of the soil is become high. So by this three way, first reaction is take place. Now we talk about the second reaction. So it is said that it takes place considerable time. It takes considerable time in a cementing action. The cementing action, also called the pozonic action, is not completely understood, but it thought to be reaction between the calcium from the lime with the available reactive alumina or silica from the soil. So first one is quick, immediately. First reaction is happening very immediately. And second is take place requires some amount of time. And during first reaction, ion exchange is happen, double dispersion of double layering happen, and expansion of the double layer also happen. But in second reaction, when we apply the line, it takes time, and also it create some cementing material through some pozzolanic action, and this it is all predict that this cementing material is formed due to the chemical reaction between the calcium which is come from the lime and the available reactive material from the soil, uh, that is alumina and silica. So by these two by these two reaction, this lime is stabilize the soil. So here one this ascending order, we can say descending order is given through its chemical reaction or cation exchange. So we know that the and this uh, reaction is take happening different factors, or we can say it depends on different factors, like the whether it is monovalent or divalent or trivalent, whether it the electrons, outer electrons, or we can say affection between the electrons and the proton, attraction between the proton, or radius of the uh, atoms, like different way this ion exchange is happen. So it is said that uh, sodium is less attractive, or we can say sodium is less cation exchange than the calcium. So it is also said that this portion, up to this portion, is highly expensive clay. This up to this portion is moderately expensive clay, and this portion is low expensive clay. So by this cation exchange, we can identify whether these clay minerals is highly expansible, moderate pressure, or low expansible. So here in the next slide is given the pozzolanic reaction. That means chemical reaction here it is given. That means when we apply hydraulic slake lime or calcium hydroxide to the silica, it is formed the calcium silicate hydrate. And when we apply the calcium hydroxide, that means slack lime, to alumina, it is from the calcium aluminate hydrate. These two are called the lime cementation mineral. So here one chemical reaction is given calcium hydroxide plus carbon dioxide. It is from the calcium carbonate plus H2. By this way, this cementitious material is formed. So now we discuss the lime stabilization design. That means what are the step we or what are the procedure we apply during the application of the or what are the step we follow during the application or before the application of the lime into the soil to stabilize the soil. So first step is to check the suitability whether the lime is suitable for this type of soil or not, or from our soil or not. First we check. For that, the basic test is sieve analysis or gradation, or find out the adderable limits or organic content, solvent content. So these few factors is depends or governs the lime application. That means whether we apply lime this type of soil or not. This by this four factors is governed. So first one is waste sieve analysis, and for this we apply this. We use this course STM C1 C6 or IS 27204 uh, for attribute find out the attribute units. We also use this type of course IS 2720 part 5 for find out the organic content. We use the IS 2720 and also we find the sulfate content. So after finding these, we can say that by different charts or by different codes, uh, th- this soil is suitable or not for this line, and if it's suitable, if it's not suitable, another technique is we use to stabilize the ground. If it is suitable, what amount of or how much amount of lime is required, what type of lime is required, we can study. So the second step is the initial line content. After finding the suitability, we now find about the amount of lime content. So what amount of lime is used to stabilize that amount of soil. So we need to find out. After finding out, we mixing this lime to our soil, and then uh, uh, after that, to further improve, we use the compaction. So for that we use uh, proctor compaction. So by proctor compaction we determine the soil optimal moisture content or also soil maximum density. After applying this lime and compacted this lime, we prepare the one specimen from the stabilized ground, and this specimen is tested in different way to uh, to give an idea that whether this life stabilization is achieve our goal or not, whether it is improve our targeted strength or not, like that. So in step 5, soak specimen usage testing we apply. That means soak specimen we apply because we in extreme condition when there is a flood, the soil is underwater or ground is given or going underwater. So it is very extreme case. So to test our specimen, we soak our specimen in water for 24 or 4 days. After this, we find out the strength. For finding out the strength, we use the universal compression testing machine, and by this way, we find out the compressive strength of the soil, uh, and give an idea that whether this soil is suitable or improvement is suitable uh, for our uh, ground or not. And then we can make a statement that uh, further we use or not this line, like that. Now we take a 5 minutes break. After that, we continue the rest of this our lecture. Uh, so now we take 5 minute break. After that, we start again from this benefits point. So now we take 5 minutes break. Please stay on the line. So, welcome back. So now we discuss further points about this line stimulation. So here now we discuss about the benefits of line stimulation. So first point it is made that it is used to for soil plasticity, modify the soil plasticity, density, strength by addition of lime to the soil. Then it is discussed that lime generally increase the plasticity index of low plasticity soil and decrease the plasticity index of high plasticity soil. And because of the reduction in the plasticity of plastic soil due to the addition of lime, the soil becomes more friable. Friable means more dry and it is easy for handling in the field. Addition of the lime cause a reduction in maximum compacted density and an increase in the optimum moisture content. In general, lime increase the strength of almost all type of soil. So these are the different benefits for the lime stabilization. So now we discuss about the construction of lime stabilized soil. How it is constructed in the or how can it is used in the field. So construction procedure of lime stabilized soil base are similar to those employed for the soil cement. That means it is similar to or the procedure of the soil cement or cementing stabilization of the cement stabilization. With the difference that more time is allowed for placement operation of the lime. That means lime stabilization takes more time than the cement stabilization. The relaxation is possible as the lime soil cementation reaction is relatively slow. So for this, relaxation is sometimes possible. That means some amount of time is given to react the lime with the soil, which is not in the case of soil cement. That means cement stabilization. The adequate care should be taken to prevent the carbonation of the lime. It means during the application of the lime, the carbon dioxide is or in air or atmosphere, carbon dioxide is react with the lime. So this should be prevented during application of the lime. Then we discuss here the sequences of the lime stabilization, construction of the lime stabilization. So first one is clarify the base. Clarifying means that means we some scratches or we can say some depression is created through drawser onto the soil like this soil, which is also similar to happen in the uh, field or you can say rice field or like that. Then we pulverize the soil. Pulverize means we uh, soil we create or we convert the soil into finer state. Then first we clarify the base, then pulverize the soil, then spread the lime. Spreading the lime over the soil, over the ground. Mix the lime and soil. Mixing is happening, and then add water if necessary to bring the optimum moisture content. That means we apply the water which is similar to the ground optimum moisture content. After that, we compact the mixture. Similar way by some roller or seafood roller or smooth wheel roller. Like that way, compact the mixture and shape the stabilized base. And some base is created and cured. Then most important stage is curing. Cure, keep the moist and traffic free for at least 5 days and add wiring surface. After that, wiring surface is added. So curing is take place and during this curing, no traffic loop is applied onto this surface and this curing should be at least 5 days. And during curing, moisture content should be maintained. And after that, one adding wiring surface should be placed over the lime stabilized soil. So here some pictures is shown for the life procedure during the stabilization line. So here it is say given about the scarify. So by this way we scarify the ground. Then after that we spreading the lime and we apply the moisture content or water onto the lime, adding water, and then mixing with some seafood roller or we can say some smooth roller. Like that way, then compacted. Like that way, we stabilize the ground with lime. Now, we discuss about the type of soil for chemical stabilization. That means this chemical stabilization, when we use this chemical stabilization, after the different soil we can use. So it is said that experience showed that lime will react with many medium, moderately fine and fine-grained soil to produce material of decreased plasticity, increased workability, and reduced soil and increased strength. So this soil particle should be moderately fine and fine-grained. That means from moderately fine to fine-grained soil is used to stabilize the uh, ground uh, for by lime. And here one different classification of soil is given which is suitable for the line, and it is based on the USCS classification, which is similar to our IS classification also. So here different soil classification given is CH, CL, MH, which is we already discussed in our soil mechanics class. That CH mean chemical high low high plasticity chemical. And CL means low plasticity chemical. MH means high plasticity silt, high compressibility silt. ML means low plastic compressibility silt. Like that way, different soil particle is suitable for this lime stabilization. Now we discuss about the mechanism of the soil stabilization with lime. How it is happened in the actual field. We discuss this mechanism. So it is said that when adequate quantity of lime and water is added, the pH of the soil is quickly increased to about 10.5, and which enables the clay particle to break. Due to the increased pH, we already discussed that the bonding between the clay minerals, that means silica and alumina, is breakdown. This silica and alumina are released and react with the calcium from the lime to form the calcium silicate hydrates and calcium aluminate hydrates, which two are called cementitious material. So here it is given the chemical reaction of the calcium silicate hydrate and calcium aluminate hydrate. So one point is given there. Uh, Calcium silicate hydrate or calcium aluminate hydrate are the cementitious product, similar to those formed in the Portland cement, and they form the matrix that contributes to the strength of the lime stabilized soil. So this cementitious material is similar to uh, this which is used in the Portland cement, and which is help to increase the strength of the soil. So now we discuss about the some factor affecting during the application of the lime stabilization. So what are the different factors governs the lime stabilization? So a few points we already discussed. So it is said that it depends on the soil type, lime content, compaction, curing time, and mixture. So these are the different governing factor which is which is take care during the life stabilization. So one by one we discuss now. First one is soil type. We already discussed that the soil type is in between the moderately fine to fine grain, and this soil type should be reactive in nature. That means mostly it should be clay or silty soil, which is mostly reactive in nature, which means the soil should react with lime content when added. To react with lime, the soil should contain pozzolana in good amount. Pozzolana in the sense silica and alumina should be present in this soil. Then only the reaction in between the lime and soil is happened and cementitious material is formed. When the lime is added to the pozzolanic soil, in presence of water, calcium hydroxide forms reacts with siliceous or aluminous material of the soil. That means silica and alumina of the soil and form a matrix with cementitious properties. This reaction is called pozzolanic reaction, similar to the cement reaction of the cement. So this reaction will increase the strength of the lime soil mix, and strength gain is gradually increased with the age since the pozzolanic reaction continues for very long period. These poems we already discussed in a few previous slide. It is further here it is written in detailed way that when we apply this lime, the soil should be in reactive nature. That means soil should be in clay or silt. Presence of clay and silt should be there. And also there should be pozzolanic content also should be present. That means silica and aluminum content should be present. So after that, when we apply the water, they form the some cementous material, and like that way to cementous material form. One is calcium silica hydrate, calcium aluminate hydrate, and this reaction is called pozzolanic reaction. And we know that this reaction is continuously happening, and it is a continuous reaction. So, and the stain due to this reaction, stain graining is already happening, and for a longer period of time, the strength of the soil is increased. Hmm. Now we discuss about the lime type. How what are the different types of lime we can use in our food? So here it is said that we can use quick lime and also use the hydraulic lime. And we said that quick lime is more effective than the hydraulic lime. But however, there is only slight difference in the final result. That means there is no difference uh, in the final strength. If quick lime is used, care should be taken by the workman, otherwise skin burn may occur. So quick lime is very effective, more effective because it is quickly react with the soil and quickly given the strength. But in for a longer period of time, there is no difference between the quick lime and hydrogen lime in case of strength. But if we apply the quick lime, there should be some precautions should be taken because when this quick lime is come in contact with our skin, some burn sensation is happening, which is very uh, dangerous. So, in the most of the case, hydraulic lime is used either in dry powder or by some use of water. Now we discuss about the lime content. How much lime content is used or required for during our stabilization. So it is said that when the lime is added to the soil in presence of water, plastic limit increases, thereby plasticity index decreases. When the lime is added further, after a certain point, the plastic limit start decreasing. This point is termed lime fixation. So applying lime, plastic limit increases first. Then due to plasticity, we know the plastic index is equal to the liquid limit minus plastic limit. So plastic limit increases. So by this way, plastic index is decreases. But when we apply the further lime, uh, plasticity after a certain point, plastic limit is decreasing, and this point is called line fixation point. So to obtain a desirable stability, plastic index should be very low, or else I can say zero, which means mm, make the clay or soil as a non-plastic, which is good for our construction. Because if plasticity is present, or plastic nature of soil is present, soil may be shrinkage or soiling nature of the soil may be increased, and expansion or soil of the soil may be increased, which is not good for our construction. Sometimes foundation may fail, or sometimes in road pavement is failed due to that. So when we apply lime, plasticity index is reduced and soil become non-plastic, which is good for our construction. Adding proper quantity of lime also increase the sinkage limit. That means which is also good because we know that if increase the sinkage limit mean the increase the strength of the property soil. Soiling can also be minimized by increase the lime content. we know that lime is good at a affection power in water. It absorbs the water. So due to this, the soiling and sinkage nature also reduce of the soil. Now we come about the compaction. So to obtain the greater strength of limestone mix, density of mix should be greater. And to higher density, we use some equipment, simple equipment, which is also used in compression like smoothing roller, shift foot roller, like that. Lime soil should be compacted at optimum moisture content, at which soil get the maximum dry density or compacted density. So this 2 point is similar to the our compaction chapter. That means when we apply for greater strength, we need the greater density, and for greater density, the soil should be compacted at a optimum moisture content. Then only the maximum dry density or compact density is achieved, and due to this, indirectly the strength of the soil also increase. So for that, we need to compact the soil in optimum moisture content by some equipment like seafood roller, smooth roller. Now come about the curing. Discuss about the curing. The curing is also an important factor in achieving the good stabilized lime soil mix. Proper curing must be provided for the mix, especially during the initial stages where rate of strength gain is rapid. But this strength gain is dependent on the temperature of that area. For low temperature region, rate of strength gain is very less. For freezing zone, it is almost zero. Humidity also affects the curing and rates of strength gain of the lime soil mix. So these are the point about the curing. So we know that to react with the soil, lime react with the soil, it takes some time, and it also takes some moisture. So for that way, we maintain the moisture content of the soil. For that, we require some amount of time, and it also depends on the temperature of the area. If this freezing zone, if there is a temperature is very low, then the reaction between the lime and soil is become very less, and gaining of the strength also very less. And like that way, so for that we use we also maintain the temperature of the surrounding soil also, and it is best for applying in summer when temperature is above below, also above very above required temperature. Now we discuss our additives. Additives are materials which are added to improve the lime soil mix to improve its strength. That means lime, when we apply lime to the soil, it is increase the strength of the soil. But this reaction is accelerated this reaction. We sometimes use some additive, and due to this additive, the reaction is happen very quickly, and the strength gain also happen in very quickly. So indirectly, additive is increase the strength of the lime soil mix. Some additives generally used as a like Portland cement, fly ash, and sooty. So these are the few additives which is used during the limes to increase or to accelerate the lime soil reaction. If fly ash is available as a waste product, then it is most recommended additive since it gives desirable strength at a economical. So we can use fly ash if as a waste product. We know fly ash is a waste product, so we can use this waste product during this life stabilization, and which give also the very good desirable stem and also economic. Chemical additives like sodium metal silicates, sodium sulfate, sodium hydroxide also used during to accelerate the reaction between the lime soil. Now we discuss about the behavior of the lime treated soil. So it is said that research over the time indicates that properties of treated soil affect the strength gain. So soil pH, organic content, quantity of exchangeable sodium, clay mineralogy, natural drainage, weathering condition, extractable iron, carbonates, and silica alarm ratio are all some of the properties which influence the gain of the strength. So these are the few factors which is govern the lime soil reaction, and it is discovered by time and by some research. The stabilization of acidic soil using lime resulted in lower compressive strength than the uh, that of the alkali soil. We know that when we apply the lime, it is the soil become alkaline. But if the soil is acidic, this lime, which is alkaline in nature, it is react with the soil, and soil become neutral, and then after when we apply this lime, the soil become further alkaline, and lime soil reaction is happen. Because of that, the, it is not reach its compressive strength. But when we apply this lime soil in alkali soil, which is there is no need to neutralize the soil first. It is already alkaline in nature, so directly soil is react with the lime. So for this reason, we achieve our targeted strength or compressive strength, which is more than acidic soil. The lime and cement stabilized soil are less vulnerable to attack the organic chemicals in comparison to the untreated soil. We know that some untreated soil is very vulnerable to the organic chemicals. So when we apply this lime or you can say cement to stabilize the soil, this this soil become less vulnerable. The success of the lime treatment process is highly dependent on the available lime content, curing time, soil type, soil pH, and cleaning. These points or factors we already discussed. We already discussed about the lime content, curing type, soil type, pH, and cleaning. These are the factors which is govern the lime treatment process during the stabilization. Now we discuss the cement stabilization, or we can say soil stabilization with cement. So we know that one of the common method of soil stabilization is to mix soil with the cement to form a material known as soil cement. Soil cement can be defined as a mixture of the soil and measured amounts of Portland cement and water and compacted to a desired density. So this soil cement method is very common and most popular. We directly apply the cement to the soil, which is nothing but Portland cement, and mix water. And after that, in similar way, which is apply in the lime uh, stabilization, we compacted the soil and achieve our desired density. The soil cement technique has been practiced almost 1,000 years, and it serves to amend the mechanical and engineering property of the soil. It is very old technique, almost 1,000 years old. Sorry, 100 years old. Sorry about 100 years, not 1,000, 100 years, and it serves to amend the mechanical and enable. That means it improves the soil mechanical properties and also soil engineering properties. The mechanical properties like that is increase improve the uh, void ratio, porosity, density, like that. In engineering property like that, it will improve the cohesion, internal friction of the soil. Soil cement has been used as a base material as an adoption of improved measure in a many projects, as such as slope protection of dam and embankment, pavement of highways, building pads, terminals of rail and tracks, parking lots, channel and reservoir lining, mass soil, placement of for dikes, foundation stabilization. That means these are the different application of the soil cement. And you can see that this has wide variety of application, wide range of application. Use dam, improve, stabilize the slope of the dam, pavement of the highways. Like that way, different way, this soil cement is used, and it is very popular to stabilize the ground. Now we discuss about the controlling factor of the soil cement. So it is said that the performance of the soil cement mix depends on the availability of the soil or cement react with the mixing soil. And there are four main properties the soil should be uh, counter, or we can say should be take should be govern the reaction of the soil cement. First one is strength of the soil, second one is permeability, then volume stability and durability. We know that if the strength of the soil is very less, then only we can use the soil cement. If permeability is more, to reduce the permeability, we use soil cement. Then to stabilize the soil regarding about the volume, or we reduce the compressibility of the soil, we can use the soil cement. Also improve the soil or durable the soil, we can use the soil cement. These are the four factors which is uh, or we can say these are four governing factor of the soil to which depends on the reaction of the cement with the soil. It is said that one point is that the durability can be enhanced with the additives. The choice of the specific additive depend on the type of the soil, service that is required to provide and the surrounding environment. That means we can improve the durability of the soil by some additives. And these additives depend on the type of the soil, service, and also the surrounding environment. That means what purpose it is used, it is also depend what type of soil it is used, which is also dependent, and surrounding environment also whether it is humid in nature, whether the surrounding environment is very hot or cold, whether it is very rainy or dry. These the factors is uh, depend governs to choose the additives to increase the durability of the soil through soil cement stabilization. Now we discuss about the suitability, soil suitability for the soil cement. So it is said that the soil material in soil cement with almost any combination of sand, silt, clay, gravel or cast stone. That means the soil cement is used wide variety or wide range of soil to stabilize. That means sand, silt, gravel, any type of soil it can use. Also, it can use in slag, lime rock, plus wide variety of waste materials, including cinder, fly ash, foundry, sand, and skimming, gravel pits to stabilize the ground. All granular based roads, with or without the bituminous surface, can also be reclaimed to make great soil cement. That means we can reclaim all granular base also, and also we can reclaim or stabilize the bituminous surface also through this soil cement. So any type of soil, any type, that means any waste material also, we can use this soil cement stabilization. Now we discuss about the mechanism of this soil cement stabilization. So it is similar, quite similar to the lime stabilization. So here it is, when water is mixed with cement, hydration occurs, meaning cementous compound is formed, like calcium silicate hydrate, similar to the lime stabilization, and calcium aluminum sulfate hydrate also created and form and also sometimes excess chemical calcium hydroxide also created, which is approximately 31%. Formation of the calcium silicate hydrate and calcium aluminum hydrate occurs when the crystal begin forming a few hours after water cement are mixed. Crystal will continue to form as long as unreacted cement particle and free water remain within the mixture. That means this reaction is continuous in process and crystal is formed due to this calcium reaction of the form creating of the these two cementitious material, and by this way after a few hours only this ground become crystal, background become hardened or hardened mass is created, uh, and this is continuously happening, and we increase the continuously this increase the strength of the soil. The process of cementation and the result of the soil cement and limestone are similar. They are in quantities too small to provide high strength cementing. That means this process of cementation, which will result with the soil cement and the lime, is quite similar. That means soil cement limestone is quite similar regarding the cementous process and the result. But the in case of soil cement, the quantity of cement is required very less, and also it gives the high strength than the lime stabilization. They reduce the plasticity of the clay soil. Calcium chloride and sodium chloride are added to the soil to retain the moisture and also control the dust, to hold the fine particle for better compaction, and to reduce the first heat by lowering the freezing point of water in the soil. So the soil cement is the soil cement same reduce the plasticity of the clay, and if we use some additives like calcium chloride and sodium chloride to the soil cement, this these additives are used to retain the moisture content of the soil and also sometimes used to control the dust and hold the fine material, and also reduce the forced heave action by lowering the freezing point of the water. Now we discuss about the building of soil cement. So how we can, what amount of, or we can say what amount of cement we can use in the field, we now discuss. Before construction begin, simple laboratory test establish the cement content. You know, by this simple laboratory test, we find out the this cement content, how much cement is required, and also find out the compaction energy, water requirement also for this soil. During construction, tests are conducted to see that the requirements are being met, and testing ensured that the mixture will have strength and long-term durability. No guesswork is involved. That means this to find out the cement content, compaction energy, and water requirement, water amount, we first some simple laboratory tests is conducted. And during this construction, this also during construction also Some field test also conducted to see that whether these requirements are being met or not, whether this achieve our goal are met or not. We can check during the construction. Now come about the mixing, how it is mixed in the uh, field. So soil cement can be mixed in place or in a central mixing plan. Like many other construction site, we one central construction mixing plan is there. Similar way, this during soil cement, we mix this soil cement in a central mixing plan. Central mixing plan can be used whether borometry is involved. Friable granular material are selected for their low content, low cement requirement, and ease of handling and mixing. So, best material is used uh, is friable granular material, which is selected for because it is required low cement requirement. Also, it is ease of to handle during mixing. Normally, pug mill type mixture are used. The mixed soil cement is then hauled to a job site and spread to the prepared subgrade. So this soil cement to mix the soil cement. Sometimes pug mill type mixture also used, and this soil cement is applied or spread over the surrounding ground. So in mixing, four steps should be followed uh, during this soil cement construction. First one is step is spreading the cement. The proper quantity of cement is spread on the field in place soil material. Then the second step is mixing. The cement, soil material, and necessary amount of water mixed thoroughly by any of several types of mixing machine. Then third step is compaction. The mixture is tightly compacted to obtain the maximum benefit from the cement. No special compaction equipment is needed. Roller of various kind, depending of type, can be used. Soil type can be used. Mixture is cemented permanently at a high density and harden the soil cement will deform or consolidate further under the truss. So in compaction, we can compaction is used to maximum benefit to achieve the maximum density or indirectly we achieve the strength. For that, no special equipment used. Simple roller, smooth roller is used, and we achieve the high density and hardened soil by this compaction. Then the fourth step in mixing is curing. It is final step and to prevent the evaporation of water to ensure the maximum strength development through the cement hydration. And this curing is used to prevent the evaporation of water and to ensure the maximum strength development through the cement hydration. A light coat of bituminous material is commonly used to prevent moisture loss. It also forms part of the bituminous surface. So the curing is required to uh, for cement hydration and to achieve the maximum development, strength development. And for that, sometimes a light coat of bituminous material is applied over the soil to prevent the evaporation of the soil. So, like this four-way, like the four-way, we mix or we apply the cement on in the ground to stabilize. Now we discuss about the performance of the soil cement. So soil cement thickness are less than those required for the granular base, carrying the same traffic load over the same substrate. So when we apply the soil cement, it actually reduces the granular base. If we don't apply, then the required granular base thickness should be high for the same traffic load and also for the same substrate. So the soil cement actually reducing the thickness of the granular base. So we can say that this is economical because the thickness of the pavement also reduced by this way. The material cost also become reduced. This is because the soil cement is a cemented rigid material that distributed loads over broad area. This means we know that granular material is not rigid material. We can say uh, there is no cohesion in between the granular material. So while we can apply the point load or heavy load on the granular soil, the point to point action is distribution of the uh, load is happening, which is not good for the load distribution. While we apply soil cement, it become rigid material, soil become rigid material as slab-like type of structure is created. And this slab-like structure is easily distributed the load over the large area. So the failure of the soil become less for this. So it is said that its slab-like characteristics are unmatched by the granular base. That means the slab-like characteristic means the load distribution pattern of this uh, soil cement. Hard, rigid soil cement resists the cyclic cold, rain, and spring through damage also. That means when the soil cement become hard, it also resists the cyclic cold, rain, and spring also. Specimen taken from the road show that the strength of the soil actually increase with age. Some specimens were four times as strong as the test specimen made when the road were first opened to the traffic. The reserve strength accounts in part for the soil cement's good long-term performance. So we know that the reaction of the cement is a continuous reaction. It means over the period of time, the strength of the soil become increasing. So this is helpful for the longer duration of time or longer performance. This is helpful. So this soil cement is beneficial for the uh, larger project where we need the strength, more strength over the period. So this is beneficial. Now we discuss about the cost. Cost. The cost of the soil cement compares favorably with that of the granular base pavement. When the built of for equal load carrying capacity, soil cement is almost always less expensive than other low cost pavement. That means when we build soil cement, one is built for soil cement by another one is for granular base pavement. We see that for same amount of load carrying capacity, soil cement is cheaper or require less amount of cost, and also it is become economic. So economy is achieved through the use of or reuse of in place or nearby borrow material. That means further we can reduce the cost by use of local material during the soil cement. No costly hauling of expensive granular base material is required, and thus both energy and material are conserved. This means during when we apply the granular base, uh, the granular material should be uh, come from some great distance because the granular soil is not available readily. So to for that hauling cost of this granular base is more than the soil cement when we apply the local material during the soil cement. And by this way, we reduce the energy and material cost also. Now we discuss about the concern on using lime and cement stabilization. So what are the concerns should be taken or what are the precautions should be taken while using the lime and cement stabilization. So it is said that a serious concern has been recognized. For instance, where calcium-based stabilizer has been applied to the soil containing the significant amount of the sulfates. So we need to uh, address the uh, sulfate amount, or we need to check the sulfate amount in the calcium while applying the this stabilizer in the soil. While lime has been proven to minimize soil in many expensive soil, a number of notable cases have been shown that long-term reaction with sulfate-rich soil can lead to generate secondary minerals such as intriguite, intriguite, intriguite and thaumasite. This thaumasite or intriguite is a crystalline nature. So crystallization of this material may cause expansion to treat soil and damaging heat to overlying pavement soil layer over the longer period of time. So this point is said that uh, actually we use the lime for reduce the soiling and sinkage nature, but if the sulfate amount in lime is more, the sulfate after a long period of time, the sulfate amount reacts with the soil and creates some crystal mineral that is intricate and thorosmite. And due to creation of this mineral, which is crystal in nature, the heat or expansion of soil is happening over the period of time. And due to this, the pavement and soil over become failed. A number of studies have been conducted on anti-diet generation and have proposed that a tolerable threshold level of sulfate usually measured as a soluble sulfate. So we should maintain the tolerable threshold level of the sulfate while using the lime or cement in the ground. Sulfate is a common in residual weather soil, especially in semi-arid tropical environment. So we cannot use the residual weather soil and semi-arid region this lime stabilization because here there the sulfate amount is more. So due to this, if it is for longer period, there are some crack or damage may be happen due to the exposure of soil when sulfate is present. Now, further concern is taken that lime stabilization is also known to alter the compaction characteristic of the soil, resulting in an increase in the optimum moisture content and reduction of the maximum density. This can advantageous in case whether the natural soil has a relative high natural moisture content, making it easier to achieve a particular compaction specification. Further, where moisture content is critical to the desired engineering properties, care needs to be taken not to use too much lime, or the drying effect may cause the treated soil to dry to below a specified minimum level. So when we apply this lime may cause is to increase the optimum moisture content and also reduce the maximum dry density. So, and we know that the moisture content is very critical for our engineering property to define our engineering property. So there should be maintained that the dye density should not fall uh, below a certain level, or maximum dye density should not fall below a certain level while applying the line. And for that, the amount of line should be minimum for that. As a general rule, one might expect the maximum density of lime stabilized soil to decrease on the order of 0.5 to 1% of the untreated dry maximum per percent lime area. That means the maximum dry density should not be reduced to from 0.5 to 1% of the untreated soil. So this should be taken care of. The optimum water content is you will usually increase 1 to 2% while applying the line and from the actual moisture content. And for that also we also need to check the lime content, and we use or we maintain this scale also or point also. So here one graph is shown that based on the dye density versus water moisture content. See that without line, the graph is higher. Also, when we apply the line, the graph is lower. That means the maximum dye density is higher than when the without line is than the maximum dye density with line. And also, we see that the optimum moisture content of the without line is lower than the optimum moisture content of the with line. So by this way we can see that after applying the lime, the density is reduced, and the same time density is reduced, and optimum moisture control is increased. So now we discuss about the use of fly ash. How we can use this fly ash during our soil stabilization. Okay, so chemical stabilization. So it is said that fly ash can be used as a soil stabilizer or the soil improvement admixture. Fly ash is commonly used in conjunction with other admixtures such as lime, cement, bitumen, and other. We already discussed about that to enhance the improvement characteristics and or economics of each. That means it also we know that fly ash is a waste material, and this is good for the increase the strength also. And due to is we know the is waste material, so it is become very cheap also. So economy of the project also, or cost of the project also reduce. For example, fly ash used in addition to cement as a admixture will lower the permeability, increase the stiffness, and reduce the shrink soil tendency. So see, it is similar to the lime and cement stabilization also. In general, one material may provide effective treatment of a particular attribute of the soil, which another admixture may not. An admixture may also provide a pre-treatment of the soil, enabling more effective treatment by additional admixture material. This often seen where lime is first used with clay soil to make the more friable or less plastic, therefore making the soil easier to mix with the cement and soil. So it is said that sometimes admixture is used before the treatment. So one admixture is use the lime with soil. Or when we use the lime, soil become very friable, therefore become dry, and also become non-plastic. So due to that, we can use the soil for further modification with the cement, and then this is become very easier to handle. And last slide, today's last slide, you said that lime or flies and lime cement flies are common combination used in the construction, where soil may be wet or and or plastic clay are encountered, but the soil is insufficiently reactive. The lime will reduce moisture and plasticity, making the soil more workable, while fly ash will provide a source of polygenic material to enhance the cementation station's reaction. If a higher strength and stiffness are desired, cement may also be added. So, uh, lime fly ash combination or lime cement fly ash combination we use. And when we use it is wet soil or plastic soil, soil should be reactive. And for that, sometimes we use the fly ash, which contain the polymer material, and cementitious material is kept. Like that way, we improve the soil and soil become very stiff and become high or higher strength should be gained. Combining polymer and bentonite with soil has proved to be an effective hydraulic barrier with many advantages, including self-sealing capability, ease of installation, and minimal degradation. So sometimes another additive also used like polymer or bentonite we use to improve the hydraulic property or we include the or use as a hydraulic barrier. So which is used sometimes as a self-sealing capability is or sometimes used as for ease of installation and sometimes and again also minimum the degradation also. Bituminous admixture are used to stabilize soil to increase the strength. Small additional amount of cement may be blended to attain the request strength specification. So, like this way, we improve our ground through the chemical stabilization. Different material is used and different chemical reaction is happening. And by this chemical reaction, the soil become cementous material is created and soil become hardened and uh, increase the strength. So up to this, we discuss the chemical stabilization of the ground improvement technique. So now we try to solve the previous year question, which is very simple. Previous assignment question. So now we one by one discuss about the previous year assignment questions. So first one is discuss that the aim of the soil stabilization to increase the soil. So we know that the main aim is to increase the strength. So to for increase the strength, we need to increase the bearing capacity. Also, we need to increase the shear strength. So correct option is here is option D, both A and C. Second question is discuss that cement stabilization is generally used for Stabilizing what? Material. We know that cement stabilization use large variety of soil. So here it is given the sand, gravel, clay. We know that all type of soil it is used. So correct option is here it is option D. Third question is asked that the strength of soil lime stabilization depends on what content of the soil type. So we know that soil should be reactive. To gain the strength is through soil stabilization or lime stabilization, soil should be reactive. And to for that, the polyolenic content should be present on the soil. The polyolenic content are the calcium, silica, and aluminum. So the correct option is here is option B, pozzolana. And question 4 asks that what is the name of the point when the plastic limit start decreasing on increasing the line? And the correct option is here the line fixation point. We know that when we apply the line, first the plastic limit is increasing. After further increasing in the line, after certain point, the plastic limit start decreasing, and that point is called the line fixation point. Question 5 asked for increase in lime content resulting. We know that if we increase the lime content, the plasticity index is decreased. So the correct option is here is option B. Question 6 asks that uh, on addition of lime to a clay soil, generally option A is given that maximum dry density decrease and optimum moisture content is increased, which is correct. Maximum dry density increase and optimum moisture content is decrease, which is wrong. Both maximum dry density and optimum moisture content is decrease. This is also wrong. So correct option is here is option A. Now from question 7 to 10, one numerical is given and which is based on our previous class, not for this class, which is discussed about regarding grouting, whatever we discuss. Uh, by this formula, grouting formula, we can solve this problem. And it is very simple formula and based on formula based. Directly use formula and you can get the result. So from questions 7 to 10, the this problem is we try to solve this problem. So first one is said that the question said that at, at a site a layer of loose medium sand with D15 is equal to zero point 0.09 mm exists between the 5 and 6 meter. That means the loose medium is exists in between the 5 to 6 meter there. We need to improve the ground through grouting. The groundwater table was at a depth of 3 meter below and sorry for that. So it is said that the groundwater table was at a depth of 3 meter below the ground surface and the permeability of the soil is given 1 mm per second. It was decided to improve the site by injection of grouting using silica gel grout having a range of diameter of 1.2 to 2 micrometer. Uh, with D85 of this grout is 2 micrometer. Viscosity is given 10 centipoise and unit of weight of this grout is 10.8 kilometer per meter. If the grout injection is planned at a rate uh, Qj is equal to 1.3 meter cube per hour, assume Viscosity of water, 1 centipoise. Radius of ground penetration is R is given is equal to 0.3 meter. Radius of injection in source is given. R naught is given 0.015 meter. So find out the gravitability of the soil. We know that gravitability of soil is equal to the ratio of the D15 of the soil divided by the D85 of the ground. So if we apply the from the data from the problem, we find out that the gravitability is about 45. So correct option is here is option B. Next is said that find out the ground to water viscosity ratio. So we know that beta G is equal to the mu G. That means uh, uh, viscosity of the ground divided by the mu W, the viscosity of the water. We know that mu G is 7 and mu W is 1. So correct option is here is option A. Question 9, it said that the ground hydraulic head using the Raphael grain formula. Find out the ground hydraulic head. So for that, one formula is given by the Raphael and Greenwood, and this is the formula to find out the ground hydraulic head. Del HW is equal to QG divided by 4 pi K into beta G, then whole into 1 by R naught plus 1 by R capital R plus 1 by R bracket close. So after that, when we put all the values from the question, we find out that A del HW, that means ground hydraulic head is about 14.2 meter. So correct option is here. It is option C. Then last one of our today's lecture. So find out it is said that the required find out the required ground pressure when the height of the ground to the injection point is 6.5 meter and the height of the groundwater table to the injection point is 2.5 meter and weight of water is given is here 9.81. So for this, one formula is given for the ground pressure is Pg is equal to the gamma W into HW plus del HW minus gamma G into Hg. So Hgp is given is 6.5, gamma W is given is 9.81, gamma G is given is 10.8, and HW is given is here 2.5, and del HW find out 14. All the values put here and we find out that 93.4 kPa. Pressure in ground pressure is 93. The correct option is here is option C. So we discuss all the things regarding the chemical stabilization and also solve the assignment problems, previous year assignment problem, which is quite similar to your assignment of this year. So now we close our session up to this with all the things I think we cover in this session regarding the chemical stimulation. Though there should be no doubt regarding this. If anything, uh, any doubt is happened, we can uh, comment on our YouTube channel. This video I am uploaded here, and we can go access to it. Also, the lectures which I am discussing here, it is uh, uploaded in Google Drive. Also, we can access. So now we stop our session. We can meet again in the next week, Saturday, which is week 10. Only 3 weeks are left for this ground improvement session. Uh, Today's session is now we reach to the session. I'm closing here. So thank you everyone.